MaxCel is a state-of-the-art formulation of the cytokinin 6-benzoyladenine, or 6-BA. As a plant growth regulator, it effectively thins apples and pears, providing key benefits such as optimizing crop load, increasing fruit size, and reducing labor costs. MaxCel magnifies nutritional stress by stimulating shoot growth. Growing shoots compete for limited resources more effectively than young fruit. As nutritional stress intensifies, the smallest fruits are unable to attract the carbohydrates they need to continue growing. This eventually causes fruit growth to halt and immature seeds to abort. When seeds abort, auxin levels decrease and ethylene levels increase as fruit growth slows. As a result, the smallest fruits drop from the tree and only the largest remain. Apples grow first by cell division and then cell expansion. Most cell division occurs in the first 3 to 4 weeks following bloom, which coincides with fruit thinning practices. The cytokinin in MaxCel stimulates cell division and increases fruit size independent of crop load. Cell division and sizing are enhanced by MaxCel's state-of-the-art formulation. This formulation includes a built-in surfactant that promotes rapid uptake under a wide range of conditions. MaxCel can be applied at rates ranging from 50 to 200 parts per million when fruitlets are 5 to 16 millimeters in diameter, depending on the objective, thinning, or sizing. Factors that cause carbohydrate deficits are just as important as the fruit size in influencing the efficacy of MaxCel. MaxCel's unique formulation provides both thinning and size benefits, generating higher returns or income to the grower, and making it the logical choice for any thinning program. Speak to your local representative to learn more about how MaxCel's natural mode of action can benefit your orchard. When using MaxCel, always read and follow label instructions.
Good afternoon, ladies and gentlemen. It's a real pleasure to start again this season of crop load management and talk a little bit about some concepts that we've emphasized in the winter, but also that I think we need to re-emphasize now. I've thrown in and titled much of this around blossom thinning because in the Hudson Valley, we're already approaching early bloom. We'll repeat and give a little more extensive presentation on blossom thinning later for Western New York and the Champlain Valley. I want to review that there's 3 things we try to do throughout the year to manage crop load, and that is in pruning, we try to prune to a specific bud load. Then this season that we're just starting with chemical thinning to try to get fairly close to the target number, and then finishing with some hand thinning. So I want to review also that the first step in this whole process is establishing how many fruits you want on the tree. Every orchard is different. The examples that I show are generally for tall spindle trees planted 3 by 11. That's 1,320 trees to the acre. If you're growing super spindle 2 foot by 11 or 2 foot by 10, or you're growing tall spindle at 3 by 12, the numbers are slightly different. But for this illustration and to guide most growers, we're looking at on Gala targeting around 1,500 bushels to the acre. That's very doable, a tall spindle, year in and year out. You have to decide what your target fruit size is, but the economic studies we've run show that targeting a mean size of 100 count fruit is where you make the most money. So if you multiply that out, that's 113 fruits per tree. Honeycrisp is a little different. When we go to that level of 1,500 bushels to the acre, it sometimes is very difficult to control biennial bearing because typically Honeycrisp trees don't get as big as Gala trees. So our target there that we think we could consistently do is 1,200 bushels to the acre. Of course, bigger fruit size with Honeycrisp with a mean fruit size of 80 count gives only 73 fruits per tree. So if you can kind of keep those 2 numbers in mind as we go through some of the presentation today, and as you work with your own trees, it'll help guide you on really what we're trying to achieve. We suggested in the winter that you try to prune to a specific number of buds and use precision pruning. Now that's relatively simple with Gala, where we're pretty sure most buds are floral buds. And we tend to want to leave a few insurance buds in case of frost or poor pollination. And the data that we've got so far suggests around 50% extra buds. So if we want 113 fruits, we'll multiply that by 1.5, we should be leaving around 170 spurs. Honeycrisp, again, it's different because the trees are smaller and we tend to need more resting spurs to avoid biennial bearing. We're suggesting a higher ratio of 1.8 buds per final fruit number. So if our target number is 73 fruits on a tall spindle tree times 1.8, that gives us 131 spurs. That's relatively low number. If you have a Honeycrisp tree that's in the on year, often you'll be in the 300 to 350 flower buds. Now, in the winter, I tried to emphasize two concepts that I want to repeat here. The first is that when you have an excessive number of buds on the tree, say, for example, with Gala, the tree takes the nitrogen from the soil in the early spring between green tip and about petal fall and distributes it to a huge number of buds. Now, none of those buds get enough nitrogen to really be healthy and be strong. The same thing happens with stored carbohydrates and with root-produced cytokinin hormones. They all come up from the root system. When you have too many buds on the tree between green tip and fruit set, none of those buds get enough of these stimulating inputs to really do well and produce big spur leaves and a decent bore shoot. And so what you have is small, weak spurs, and they tend to produce small fruit. In addition, they have lower fruit set and they are more biennial. Now, this is especially problematic with Honeycrisp, where if we've got way too many buds, they tend to be weaker and then they are very alternate bearing. With Gala, this is especially important because if you want large fruit size, you can't have weak buds. We've known that, but we're trying to quantify it more this year with a group project between Michigan, New York, and Washington and North Carolina, where we're measuring bud diameters in trees. But generally, we know that small diameter buds give small fruit. And so when we prune, if we can get rid of the excess number of buds, as the tree starts to grow in the spring, it'll put its resources into fewer buds, and they're all better buds. The second and important reason is related to what the seeds in those little tiny fruitlets do to flowering for next year. So for Honeycrisp, it becomes extremely important not only to prune to the right bud load, but then also to reduce the number of flowers within the cluster as quick as possible, because every seed is producing gibberellin hormone. Gibberellin is called the anti-flowering hormone. It inhibits flowering. And in fact, there's one company that's working on the idea of spraying gibberellin in the off year to try to prevent too many flower buds. And that may be something of the future. I think it's a little bit unpredictable, so I've not really pushed it. But we know that these seeds are, I guess I didn't go there. We know that the seeds produce gibberellins, and they tend to export that gibberellin into the bud for next year and prevent it from flowering. So the earlier in the season that you can get the fruit number down to something close to your target, the less time the seed-produced gibberellins are on the tree inhibiting flowering. So I want to give two examples here with Honeycrisp. Let's say you followed our recommendation and you pruned Honeycrisp to 130 initial buds by doing a rough pruning in the winter, and then in the last few weeks, and in fact, there's still time to do this, you've gone back and where you had excessive flowering, you cut off buds and more branches to reduce it down to this target number of flower buds of 130 on a tall spindle tree that I've described. Let's contrast that to a lightly pruned tree that's in its on year. and it has 250 initial buds, flower buds. When you calculate the number of seeds by taking each bud has 5 flowers in it, and each flower can produce a fruit with 10 seeds, you come up with an initial seed load of 6,500 seeds per tree, even when you prune correctly. But where you lightly prune, you come up with 12,500 seeds. Now, those seeds really start producing gibberellin just a few days after fertilization. So let's consider the period between bloom and when you could thin off some of those, let's say at the 10 millimeter timing, which is about 2 weeks after bloom. During that whole 2 weeks, all those little seeds are producing gibberellin, inhibiting floral initiation. Now, in the first case, let's assume that we not only pruned well, but we're willing to blossom thin. Now, what blossom thinning does, hopefully, is remove all of the lateral bloom within a cluster, leaving only the king. That would be ideal. So in that case, if you prune correctly and then blossom thin, you could get down to 1,300 seeds soon at petal fall, really. That's a manageable number. With that number of seeds, we can get repeat bloom. But in the alternate case where you didn't prune very well, you lightly pruned and had way too many buds to start with, and then you were unwilling to thin it bloom, and you waited until the normal 10 millimeter timing, you carried 12,500 seeds for at least 2 weeks. But even after you thin, if you could thin every one to a single, which we often can't do, but even if you could, you'd still have 2,500 seeds per tree. And it's this seed number that gets us into trouble. Carrying fruits for too long before we get them thinned off and them doing damage to our flower initiation. Because of this, we're really pushing to try more and more blossom thinning with both Gala and Honeycrisp. Now, let me continue with this slide that I showed in the winter, which came from Pollyanna's work when she was here. The slide on the left, figure on the left, shows Gala flower initiation and how many days after bloom. So you can see that the red line is where you would have the king blossoms differentiating. And it starts about 60 days after bloom, and then it continues for a period of time and terminates about 110 days after bloom. Now, 110 days after bloom is in late August, and 60 days after bloom is in early July. So Gala tends to initiate flowers in July and August. And look at the laterals, then you can see that they even do initiate much later. So you can carry extra fruits on Gala and thin them off at hand thinning and still get good repeat bloom, in addition to the fact that it's not very biennial. Fuji, in contrast, is much more biennial, and it has the problem that it starts its flower initiation earlier, somewhere around 50 days after bloom, and it ends it about 90 days after bloom. So it starts in early July and ends about the end of July. If you're really good and do early hand thinning, you can manage Fuji without too much trouble in biennial bearing. But when she looked at Honeycrisp, that flower initiation starts about 35 days after bloom, and it's all finished by about 70 days after bloom. So that means it starts flower initiation, at least what we can see, in mid-June, and it ends by early July. So gibberellins produced in the seeds of fruits that eventually you're going to thin off do tremendous damage in terms of return bloom for Honeycrisp. And we have to get them off extremely early. People in other parts of the world, and my experiments here show that the best way to break biennial bearing of Honeycrisp is to thin at bloom. Another way to look at that same data is to look at flower initiation, and Honeycrisp really is a June, mid-June to the late June time period. Minneska, Sweet Tango, early also, McCown, Fuji. Those biennial ones we've known for years about McCown and Fuji, you have to hit them hard at petal fall. Well, it does even better if you thin them at bloom, like we're suggesting for Honeycrisp. Other varieties, and you look at Gala in particular, it has flower initiation quite late. So that leads me into what I really want to talk about today in the few minutes I have left, and that is we are starting this annual process of sequentially applying chemical thinning sprays, starting with a blossom thinning spray. I really encourage you to consider blossom thinning, and I hope to walk you through it a little bit today, and then next week for Western New York and the Champlain Valley, give even more detail specifically about how I would do blossom thinning. We'll have other webinars later in the season to talk about what to do at petal fall and at the 10 to 13 millimeter and the 16 to 20 millimeter, and talk about improvements to the carbon balance model and the fruit growth rate model. But for today, let's just focus on blossom thinning. To use this pollen tube growth model, which is on the NUA website, it requires you to measure style length of 20 flowers in a block. Now, you could do more or less. I think 20 is enough. You remove the petals from the flower, but not the sepals. So what you see in the picture on the right, the petals are gone, but the sepals are still there. And then we measure from the flat part of the sepals to the tip of the pistil. That's a millimeter measurement. We input that number into the model. The second important step is determine the moment. And I use that word kind of on purpose. I'd like to know exactly what time of the day enough king flowers are open to match the target number. So let's go back to our targets. With tall spindle honeycrisp, we're looking 73 apples. Maybe you could go 70 to 100 flowers. When a 70 to 100 flowers are open on a honeycrisp tall spindle tree, that's when you start the clock of the model running. With Gala, it's a little bit higher number, so you would kind of be out in your orchard or somebody be assigned to kind of watch. And if it's 10 o'clock in the morning, when you get on Gala 100 to 130 king flowers open, that's when you start the clock. If it's 6 p.m. in the evening, you start it then. Now, some people get annoyed at this little requirement for precision, but it really does make a difference. I don't expect people to stay up all night watching this and counting trees, but just try to get sort of the best guess of around the time of day that you have enough flowers open to start the clock. Once we have that target number of king flowers open, the model then, when you go into new, is very simple. You input that time and it will then predict, based on temperature forecast, how the pollen tubes are going to grow over the next 3, 4, 5, 6, or 7 days. And it will predict when that pollen tube growth has grown 20% of the distance, 50% of the distance, 70, 80, 90, and when it gets to 100% of the distance. My experience over the last 4 years, I used it a little bit before my leave, but since my leave, shows that with the one chemical we have available to us, if we wait till the model says 100%, the pollen tubes have grown 100% of the distance, ATS doesn't work very well. We have to spray earlier. So with only sort of limited data and my own feel for how it's worked for me in the last several years, I'm suggesting that we spray earlier than 100% on the pollen tube growth model. This year, we're doing some more detailed studies to compare this 60%, what I recommend, versus waiting to 100% with ATS. But I don't want you to fail. And so I really suggest that you look at the pollen tube growth model, and when it gets to predicts that the pollen tubes have grown 60% down the style length, spray. Then restart the clock in the model that lets you do that, and then spray a second time when it says the pollen tubes have grown 60% down the style. If you're afraid of that number, go to 80%. But our experience is waiting till 100% with ATS does not work. And it's the cause of many people getting frustrated with this. Now, what are our options for thinning? We have one caustic chemical that we can legally spray and a couple of hormone type sprays. Let me first cover the caustics. You all know that many people out west use lime sulfur mixed with oil. Fish oil is the best, but we've been unable to get a label for that in New York. And the one company we had the hopes for turned us down flat this year. They're afraid they're going to get sued. So it's not legal to spray lime sulfur with oil during bloom. The only thing that's legal is ammonium thiosulfate. And on your spray records, it can only be listed as a foliar nitrogen fertilizer because that's what it is. But we know that a secondary effect of this is that it burns the pistil, the stigma of the pistil, and it can cause mild leaf phytotoxicity, but we never have seen fruit finish problems. It usually requires 2 to 3 applications, but when used in conjunction with the pollen tube growth model, as I've just described, spraying at 60%, it can achieve substantial thinning in that bloom time period to reduce the number of fruits and their seeds that are producing gibberellins to avoid biennial bearing. It doesn't stimulate fruit size like MaxCel does, and we just saw a wonderful video on that. It just kind of has a neutral effect on size. Now, it's clear that it's not registered in New York as a thinner, but it can legally be used at bloom as a foliar nitrogen fertilizer. And we've shown repeatedly that it improves return bloom of honeycrisp. Now, a couple of important things. Some people out west have tried this at higher concentrations than I have been successful in the east. I am really afraid of going above 2.5%. So my rate range is 2 to 2.5%. So I like to use around 100 gallons of water. So every 100 gallons, you're going to put in 2 to 2.5 gallons of ATS. If you go to 3, 3.5, or 4%, like sometimes is used out west, you get so much phytotoxicity, it's scary. Now, part of the problem is that in the West, the leaves are more thick and thicker cuticle because they have stronger sunlight than we do. We have cool, wet, rainy weather, and so the foliage cuticle is not as thick, and ATS will really burn if used at 3 or 4 or 5%. I have a suggestion this year I've not really said in the past, and that is if you've got temperatures that are above 75, use the lower rate. Use just 2 gallons in 100. If you have temperatures that are below 75, which it looks like this year, mostly we're going to have temperatures below 75, I would use the higher rate of 2.5%. Another critical factor for me is the spray pattern. We often suggest for thinners that you have your spray pattern concentrated with 2/3 in the top and 1/3 in the bottom, but that does not apply to caustic chemicals. These caustic chemicals work by a droplet of water landing on that pistil and burning it. And it's the concentration of the ATS in that droplet that makes a difference. It doesn't matter the ATS that lands on the leaves or branches or anything else. It's what lands on that flower. Thus, you want to have an equal distribution of nozzles from top to bottom so that every part of the tree gets equally sprayed so that each flower can hopefully get some ATS on its pistil. Now, there is another option, and that is to use the hormone type sprayers at bloom. We've tested a lot of them, but right now my best options are either NA or NAD, which is surprising work quite well at bloom, although we're used to using it at petal fall. The timing for these hormone type sprays is not so time critical as the ATS is. The ATS, you've got to time it with a pollen tube growth model. With the hormone type thinners, you just have to spray it about full bloom. Now, what's full bloom? The exact definition is when you stand on the north side of the tree and you look at all the flowers on the north side of the tree, when 80% of them are open, 4 out of 5 flowers in a cluster, that's full bloom. That's the time to spray NAA. And it can be sprayed safely. It's very safe at bloom. It's very mild. And 10 parts per million can be used repeatedly on a number of varieties. It has almost no depression of photosynthesis at bloom, but it can truly help return bloom on honeycrisp. It doesn't give you very much thinning. So those little fruitlets stay there and they keep churning out gibberellin unless you come back right away at petal fall. And again, at 12 millimeters, that bloom spray won't help that much. But as a part of a bigger program, these NAA or NAD can be very helpful, but they don't take off very much fruit. So if you're getting close to bloom, and like they are in the Hudson Valley, get some of this product, try it. I think it does a wonderful job on Gala and on Honeycrisp, and does a wonderful job on Fuji in terms of evening out bearing from one year to the next. Also can work well on Snapdragon. But use the pollen tube growth model. My best suggestion is use ATS to prevent fertilization of many of the lateral flowers in a cluster so that you can come out of bloom with essentially 1 fruit per cluster. And if it works perfectly and you end up with about 1 fruit per cluster, then with the post-bloom thinners, our effort is to reduce it a little further to get to the target, because remember that we've left insurance buds. Now, 2 cautions. Don't spray these caustic thinners under real slow drying and wet conditions, or if there's frost. The problem with frost at bloom, now I would say that frost at tight clusters, not the same thing, but frost around bloom, early bloom to mid bloom, causes some damage to the cuticle of the little fruitlets, and ATS is absorbed way too much into the small fruitlet on the base of that flower and can cause russeting. But barring frost around bloom, it's a very safe product to spray, and we've never seen russeting with this particular product, whereas we have once in a while with lime sulfur and fish oil. Now, be prepared that if you spray it at 2 to 2.5%, you're going to see some leaf damage. I, in fact, almost have to see leaf damage to know that I've sprayed it correctly. It's not a big concern. I'm going to end with these 2 little examples. What we're trying to get you to do is start this 4-spray program and apply 1 or 2 or 3 or 4, depending on how many are needed. It has to start with this bloom spray of ATS for Gala, usually 2 applications guided by the Pollen Tube Growth Model. Now, those of you in the Valley, I'm sure that Dan could help every single one of you that's willing to try it. And he's already told me just of a couple, but I hope we get more than a couple of people trying this year on Gala and on Honeycrisp. We'll follow that up with the more traditional sprays later that are listed. And we can, if it doesn't really work, we can still react at petal fall and 12 millimeters and 18 millimeters to get this down to the right crop load. With Honeycrisp, it's a similar program, but still ATS is where it's got to start. If you have been in a biennial bearing cycle, and this is the on year, you've got to try this year. If it's the off year and you barely have enough flower buds to reach your target, or you're even under it, you can skip it this year. But that's a decision you make by evaluating how many clusters you have on the tree. If you have around 70 clusters on your Honeycrisp trees, don't blossom thin. But if you have 200 or more clusters, you need to blossom thin to reduce the number of fruits down to a reasonable number as quick as possible to stop this impact of seed-produced gibberellins on biennial bearing. Because of what I said earlier from Pollyanna, we're also thinking that we've got to start return bloom sprays on Honeycrisp earlier. I'm not going to cover this right now, but just have to keep this in mind. The Honeycrisp starts initiating flowers just a few weeks after bloom. And if there's still a lot of fruit on the tree, a lot of seeds, we can never get repeat bloom. With that, I'll stop and be happy to answer any questions. Well, let me just add one more sentence before I stop talking. If you have not readjusted the number of buds through pruning, there's still time. Pay particular attention to Honeycrisp. Go out and count some Honeycrisp. And if you're way over 150 buds on those trees, prune more off. You got to be down around 130, 140, 150 buds on a tall spindle Honeycrisp tree. If you got a super spindle Honeycrisp, you got to be down closer to 100 buds. Well, if you've got 300 buds on there, you're going to really pay for it next year. You'll really, really not have a reasonable crop next year. So I'll end with that.
Thanks, Terence.
Hi, yes, Terence, we have several questions for you in the chat box.
Yeah, we're out of time. We need to get to the next speaker. So Terence, I'd ask if you could address those questions in the chat box. There's 4 of them. And if you would reply to all of us, that would be really appreciated. And we're going to move on with our next speaker, Dr. Lailiang Cheng, also from Cornell, and he's going to talk about nutrition at this stage. And the screen is, thank you.
Thank you, Greg. Good afternoon, everyone. I'll briefly talk about nutrient management for this coming growing season. First, nitrogen. We all know that nitrogen is very important for shoot growth, leaf area development, and fruitlet cell division. So the highest nitrogen demand period for apple trees is from bloom to the end of shoot growth, followed by a slower but steady demand all the way to fruit harvest here. the total amount of nitrogen required by gala trees, mature gala trees, is the difference between the total amount of nitrogen at fruit harvest and the total amount of nitrogen at bud break. That is 20 grams of nitrogen per tree, which is equivalent to 50 pounds of actual nitrogen per acre. If you use fertigation to manage nitrogen, you want to target fertigation to the highest nitrogen demand period, from petal fall to end of shoot growth. However, if you use regular ground application, you want to put down your nitrogen between bud break and bloom so that the nitrogen will be available for this highest demand period. And in terms of rate, if you use ground application, it's generally anywhere between 10 pounds to 50 pounds per acre. For Honeycrisp, generally it's anywhere between 10 pounds to 30 pounds. For Gala, it's anywhere between 30 pounds or 25 pounds to 50 pounds. If you use 50 pounds of nitrogen, we typically suggest a split application. Half of it at bud break or shortly after bud break. The other half is around petal fall. We need to keep in mind that for the same amount of nitrogen, let's say 40 pounds to Gala, if you put down that 40 pounds of nitrogen at bud break versus you put down the same 40 pounds of nitrogen, at petal fall or even during rapid shoot growth here, you're going to have different levels of fruit nitrogen at harvest. So our data show that the later you apply the nitrogen, the higher the fruit nitrogen level will be. You need to keep this in mind, particularly for varieties that are very sensitive to nitrogen. For example, Honeycrisp. When you have even slightly higher nitrogen level, fruit quality would be compromised. So you need to keep this in mind. In other words, if your leaf analysis showed marginal nitrogen status from last year, and you have not put down any nitrogen, you need to do so fairly soon. The optimal tree nitrogen status is anywhere between 2 to 2.4%. For Honeycrisp and other varieties that are very sensitive to nitrogen, we shoot for 2%, right around 2%. For Gala, Empire, and other varieties that are less sensitive to nitrogen, you can have leaf nitrogen level anywhere between 2 to 2.4%. For Honeycrisp, we really need to take leaf samples in early July before zonal chlorosis shows up. For Gala and all the other varieties, we typically take leaf samples in early August. However, for Honeycrisp, we need to do this in early July to avoid any complication of the zonal leaf chlorosis on leaf analysis result. Once zonal chlorosis develops on the leaves, if you take those leaves for nutrient analysis, you're going to see much lower leaf nitrogen level and much lower leaf potassium level. So just keep that in mind. Potassium is very important for carbohydrate production through photosynthesis, and also very important for carbohydrate transport to support fruit growth. The potassium requirement differs between varieties. And for Gala, Empire, these small fruited varieties, and many other apple varieties, the optimal leaf potassium level is 1.3 to 1.8%. My predecessor, Dr. Warren Stiles, did a lot of work on this, and it's very clear, especially with the Empire, if you have fairly low potassium level, let's say 1.3%, the fruits would be smaller than when you have a leaf potassium level at 1.8%. So for these small fruited varieties, Gala, Empire, and many other varieties, we want to shoot for the upper half of this range. That is, 1.5 to 1.8%. For fruit potassium level at harvest, generally, the optimal fruit potassium level is around 0.8%. Our data show that with the Gala. However, for Honeycrisp, as you can see from these two charts, Honeycrisp here, photosynthesis increases as leaf potassium level increases, but reaches a plateau much earlier than Gala. Gala is 1.1% here, but for Honeycrisp, it's 0.8%. Fruit size showed a very similar response as leaf photosynthesis. Compared with the Gala here, it's almost linear response. Honeycrisp fruit size reaches a plateau at leaf potassium level around 0.8%. To build in 0.2% insurance, so we're shooting for 1 to 1.3% leaf potassium for Honeycrisp. And the corresponding fruit potassium level is around 0.6%. So the optimal fruit potassium level for Honeycrisp is about 25% lower than that for Gala. So variety-specific potassium management is important. And another aspect is the rootstock-specific potassium management. And there are data showing that G11, G41 are more efficient in taking up potassium than B9 and M9. So we really need to pay attention to this rootstock difference to minimize the risk of bitter pit. In terms of application timing, we typically put down the potassium after harvesting the crop. As fruit harvest removes significant amount of potassium from your block. For example, here, these are some of the data we obtained from Gala. As fruit yield increases from 500 bushels to the acre to 2,000 bushels to the acre, the amount of potassium removed due to fruit harvest increases from about 30 pounds to about 110 pounds. At a yield of 1,500 bushels to the acre, every year fruit harvest removes 83 pounds of potassium, which is equivalent to 100 pounds of potash per acre per year. So that's why we developed this replenishment approach or maintenance potassium application program. The idea is that we really need to put back the amount of potassium that has been removed due to fruit harvest every year in order to sustain the productivity of the block. And this approach works really well for regular bearing varieties such as Gala. However, for Honeycrisp, is a lot more trickier here, tricky here, because Honeycrisp fruit removal rate is lower. Let's say it's about 2/3 of that for Gala. And another important factor is that Honeycrisp has biennial bearing. So you can imagine if, let's say in 2020, you had 1,000 bushels of, your block produced 1,000 bushels of fruit. So that, you should put down about 80 pounds of potash, roughly 70 to 80 pounds, 70 to 80 pounds of potash after fruit harvest. However, if you have an off year this year, and then the amount of potassium you put down would be taken up and would be transported to a very limited number of fruits on the trees this year, and that would elevate potassium level in those fruits, and leading to higher bitter pit incidence. So for Honeycrisp, when we use this replenishment approach, you need to be very careful. If you are pretty much sure your Honeycrisp trees have pretty much regular bearing and this approach works, but if you expect on off years significantly, you need to modify this. Perhaps you need to put down the potassium, the amount of potassium or potash based on your expected yield for the current year, rather than last year's fruit yield. Now, for Honeycrisp, in addition to strictly managing potassium input, we need to have an active foliar calcium spray program. This is what we have been suggesting over the last many years. So starting at 7 to 10 days after petal fall, you put on 4 sprays of 1.5 to 2 pounds of calcium chloride per 100 gallons of water at 10 to 14 days interval. And then followed by 2 sprays at a higher rate of 3 to 4 pounds of calcium chloride per 100 gallons of water at 2 weeks interval starting from 4 weeks before harvest. And this program will provide about 3.5 to 4.5 pounds of actual calcium per 100 gallons of water per acre over the growing season. And the work done by Dave Rosenberger and several of us at Cornell in early 2000s showed that it is the amount of elemental calcium you put on that makes the difference. So the minimum amount you need to put on is about 4 pounds. 4 pounds of elemental calcium per acre per year. If your Honeycrisp trees have a tree root volume of 100 gallons. For micronutrients, boron and zinc are important for fruit growth. And particularly if there is some winter cold injury, foliar, boron, and zinc with urea may help the recovery of the damaged vascular tissue. Ed Stowart and Dr. Warren Stiles did quite a bit of work on this in the Hudson Valley. So the recommendation is at a pink and a petal fall, put on the following spray: 1 pound of soluble plus zinc EDTA at label rate plus 3 pounds of urea. I forgot, this is per 100 gallons of water. Okay, so 1 pound of soluble plus zinc EDTA at label rate plus 3 pounds of urea to help the recovery of the damaged vascular tissues. And this typically strengthens the young fruit growth. Last year, we launched the PL-SAP analysis effort for Honeycrisp growers. And this year, we're going to expand that to the entire state. And we would send out newsletters and emails as we approach this. And this, in this PL-SAP analysis program, we would ask you to take 30 fruit samples from a block of your interest. This has to be Honeycrisp. And then we get 2 pieces of peel from the opposite size and put the 60 pieces of peel into a Ziploc bag and throw it into a regular freezer overnight. And then we would collect the samples and squeeze the peel tissues for sap, and then for analysis. And some of the data we collected in 2020 last year showed that we really need to have a potassium to calcium ratio below 25 in early July. And the sampling times are typically July 5th, from July 5th to July 12th. It varies a bit from year to year, but we target for fruit size at 50 to 55 gram. And we also analyzed some of the samples collected last year for nitrogen. We found that a nitrogen to calcium ratio below 4 would be good. And this ratio is the number of nitrogen atoms to the number of calcium atoms, not a weight ratio, rather it's a molar ratio. And in terms of the nitrogen, the actual nitrogen concentration, we want to shoot for below 100 ppm. If the fruitlets, if the pure sap nitrogen level gets above 100 ppm, the nitrogen level may be too high. We're gonna confirm these numbers this year, but these at this point, the nitrogen to calcium ratio and the actual nitrogen concentration numbers are listed here. So that's it. With that, I want to thank all the people who did the work, and also many grower cooperators and USDA SCRI and New York Apple Research and Development Program for their support. Thank you.
Thank you, Lailiang. Fortunately, we're out of time, but if you could address, there's 2 questions at the moment pertaining to your presentation. If you could address them in the chat box.
Sure.
That'd be great, and try to answer them and select all so we can all read them. And with that, I'm going to turn it over to Janet to introduce the next 2 speakers. I'm sorry, I got one more to introduce. I'm sorry, I'm getting ahead of myself. Dan Donahue is going to talk about Apogee and Bitter Pit sprays at the pink timing. Take it away, Dan. Thank you, sir.
Okay, very good. Thank you, Craig. You can see my screen okay?
Correct, yes.
All right. Okay, very good. Okay, let's talk about Apogee at pink for the suppression of bitter pit. We have a 2EE label for the material for this use. The work started in 2016 with the idea starting in 2015 when Anna Wallace and I wrote the original proposal. What we thought at the time was that when we were looking at ways to mitigate bitter pit, that there's competition perhaps between shoots and young growing fruitlets. Perhaps if we throttled back the vegetative growth of these young shoots by using very early apogee application, maybe we would be able to shunt more calcium away from that growing shoot and into the fruit. Well, that was the idea. Okay, and it turns out I don't really think that that's what's happening, but we were successful. And so I'm going to show some data, the data that kind of backs up the recommendations. So you have an idea of what where this all came from. And what you're looking at here is the study from 2016. And what you see here is an analysis you may not see very often. It's a graphical representation of a statistical analysis of a binomial distribution for you statistical mavens out there. But what you really need to know here, if you look across the bottom, is we have a control, petal fall timing, 1 application at petal fall, 3 sprays starting at petal fall, 1 spray at pink, and 3 sprays starting at pink. So the 3 spray at petal fall is sort of conventional apogee as you would normally use for season-long vegetative growth. What we learned in 2016 in this M9 block is very high bitter pit year. The control had 44.4% bitter pit incidence after some 60 days in storage. The single pink spray down to 25.6%. And that was statistically significant because the measurement is outside the confidence interval lines. What we also saw was conventional apogee at 57.8% bitter pit. So seeing the effectiveness of pink was encouraging, The 57% from a conventional program was shocking, so didn't talk about that much. And of course, with Honeycrisp, you can't really trust 1 year's worth of data. So if we move on to 2017, this is in a different block, though also in the Hudson Valley, also M9 as T337 in this case, lighter bitter pit year. But we use 8 replications and we look at 320 individual apples per treatment. So we get quite a bit of precision. And sure enough, we saw once again the same relationship. We saw 8.4% bitter pit in the control, reduced to 4.7 in the pink spray, and 14.1 in the conventional 3-spray petal fall program. So there's a second year repeating the data. And when we go to 2018, this is staying in the same block, we were back to a bad bitter pit year in this block. And again, the control was up around 35.6%. In this case, the petal fall 3 conventional program wasn't as bad. It was actually showed a little bit of improvement, but the pink spray was down at 19.1. So 3 years in a row, we saw that the single pink spray somehow reduced bitter pit around 50% out of storage. And 2 years out of 3, the conventional petal fall program actually aggravated bitter pit. So these were trials that were done on individual trees, generally 8 replications, solo backpack. So of course, we want to know what's going to happen out in the field in grower blocks, grower applied using air blast equipment. So this particular trial was set up in Ulster County in 2017. And unfortunately, I ran out of trees, so it's 1 treatment short of what I would like to see. But if we look at the control here, which is the 4th over from the bottom, control, 12 millimeter thinning, and no calcium, you see we were up over 60% in bitter pit incidence in this block after 79 days in storage. Where we added 4 summer calcium sprays, these are POMA as the material, we did significantly reduce bitter pit down into like the 46% range or so. So that was interesting there. But when we used Apogee in an early spray along with an early calcium program, earlier calcium being the POMA product at petal fall, and then 5 sprays total on a weekly interval. So that's through the cell mitosis, cell division period. And we saw that, again, it was quite effective, that combination in reducing bitter pit. So in this study, I was interested in looking at a program which combined Apogee with early calcium sprays, and we had some success. This is a Columbia County trial here. And again, control with no calcium was up above 35%. And then if we used an Apogee 12 millimeter thinning program and early calcium, we dropped that down to somewhere around 23%, and it was statistically significant there. So once again, the program of combining a single shot of Apogee at pink plus an early calcium program did well in controlling bitter pit here. So how is it actually working? Are we getting, is it because we're throttling back vegetative growth? And the answer to that is, well, not clear at all. I guess the trouble is in science is you can't prove a negative. So you can't prove that something hasn't happened. You can only prove statistically that something has happened. At this point, I can't show that there is that relationship. For instance, here, look at the first 2 columns, control and single pink spray. And we look at terminal shoot extension, which is 65 to the left on the control, 66 millimeters to the right. They're identical. However, our bitter pit is significantly different. So we can't really tie it to the shoot growth in that case. And here's another experiment looking at mean shoot extension here where fruit was associated with the terminal shoot. So a direct competition between the shoot growth and the neighboring fruit. Again, in the petal fall conventional, where we had high bitter pit of 14.1%, we also had a reduction from 163 down to 114 millimeters in our terminal. So we had a reduction in terminal shoot growth. However, we had more bitter pit than we had here in the control. So again, and we have other studies that directly track bore shoot growth to individual fruits. That was from 2016, and we didn't see a relationship there either. So is that really the case? Is it a competition thing? Well, it might be, because again, we can't prove a negative, but so far I haven't really seen that as a relationship. But this slide's a little bit complicated, but let me just make a point here. If you look, the first 4 lines here are clean fruit, clean apples without bitter pit, conventional ProHex program, a Poma calcium early program, control, and then just single pink ProHex. And then the last 4 lines are bitter pit fruits in the same program. So take a look here with the 2 yellow arrows, those lines. So clean fruit on a conventional ProHex program. So a lot of vegetative shoot reduction. And if you look here, 789 parts per million in the stem end, 716 parts per million calcium in the calyx end. Pretty high calcium levels relative to the other treatments. I mean, here's ProHex. It was a clean fruit, but had, much lower, although statistical significance isn't always there in this data, a little too much variability. Look at the bitter pit fruit. I mean, you look at the group, and consistently it did have less calcium in the fruit. However, still, it you look down like in the ProHex. Well, you look here, this line here, the clean had this had less calcium in it. But if you look at a clean ProHex pink apple, it had less calcium than the conventional, but it had less bitter pit. So my point here is, when we talk about calcium relations in the fruit, it's not a macro issue, or it's not a global issue. It's not how much calcium you can dump on that apple and get into the fruit. It's more a question of space and time. It's a question of cations being available to localized groups of cells right at the time that they're needed during their development process. And if they're not there, then those membranes and cell walls perhaps are going to be weak, and they may express bitter pit symptoms later on. So again, just to wrap up here, on the team Honeycrisp in the Honeycrisp playbook here, the recommendation is 6 ounces per acre, not less, not 3 ounces, 6 ounces per acre in a tall spindle system. You could go up to 9 if the trees are a little bit larger. Single application at pink. And new for this year is, I like to see some heat, because Apogee is a PGR, and it behaves like a PGR. It needs to be absorbed into the leaf and metabolized. For that, you need some heat. So I want to see 65 degrees or warmer during the period of application. Also, secondly, if you're rushed to get around in the right amount of time, prioritize your M9 and your M26 blocks. You can deprioritize your B9 blocks, because chances are they're going to do okay as it is. And I really strongly advise staying away from using Apogee in a conventional sense in a Honeycrisp block, that is post-petal fall, because I think the chances are it's not going to help you. It may negate the positive effects. So with that, I'm done, and I will unshare my screen.
Thank
All right, well,
We don't have any time for questions. I think there might be one in the chat box for you, and if you want to monitor that and answer and copy everybody, that would be great.
Yeah, thanks, Greg.
Thank you. I'm going to turn it over to Janet to introduce our next 2 speakers.
all right, thanks, Greg. I'm going to go ahead and introduce the next speaker, which will be Kerik Cox. And Kerik, if you can share your screen, I think you should be a co-host.
All right, Janet, if this is it, I'm going for it then. I don't really have any slides to show, but anything that I talk about today, you can find right there at that link. It's just basically our upcoming thing. The first thing, I know we're talking about fire blight, but the first thing I want to mention is that it seems like our first really big apple scab infection period is coming around 4/29 for most of the places in New York. And if you're mostly scab focused, one of the strong SCHI materials, or if you have some mildew, rust, and some other things along with your scab, one of the ones that contains a DMI might be very helpful when getting ready for this big event. And always, if you see some of our very brief recommendations, include something like a protectant like mancozeb to go in there for some resistance management. But if you're following Janet, Mike, and Dan's predictions, you'll see that they're much more detailed for the specific regions. Okay, what happened last year with fire blight? Well, it was pretty much awful. It devastated most of New York and a lot of New England as well. And it seemed to happen in many instances for us that we had a lot of really hot, dry weather at the end of bloom, moving into petal fall. And it was not necessarily a great conditions for blossom blight, but it was really good conditions for very late, maybe rat tail bloom blossom blight, and perfect conditions to moving systemic shoot blight throughout the planting. And it seemed like around the last half of May, the last week or so of May, there was really some extreme risk for fire blight. When bloom was, like you think, I think it's over, it should be over. Really not a lot here. We're deep in the petal fall, and there's absolutely no rainfall, no dew. Was very scarce. We were doing a meeting with some New Hampshire growers, and they were pulling their hair out because how could they have gotten so much blossom blight or any blossom blight when it was so dry and it was a dust bowl? And then I began to remember that I have colleagues in the Pacific Northwest. They get fire blight all the time, and it's an incredible dust bowl. And it's got me to starting to think that even the slightest bit of humidity, when it is so high risk and so dangerous for fire blight predictions, that even maybe internal canopy humidity, or maybe even humidity from a wind where the branches and things are rubbing against the wire, or from a nutritional fungicide application. My colleagues in the Pacific Northwest often ask, like, wait, you're not spraying water. If you put water out with your inoculum, it's going to cause an infection anyway. I'm like, so maybe even things like that could start off an epidemic and just lead to the slightest bits of water that would be needed for an infection when it was apparently a very dry around that period. And then once we started moving into hot weather after petal fall and the shoots were growing, it was fairly devastating. And that's got me feeling a little more cautious about the 2021 season. Right now, Hudson Valley is starting to bloom, as everyone has talked about, and now temperatures are going to be approaching in the 60s and 70s. Depending on what crazy weather data you use, you might even see a temperature in the 80s for the Finger Lakes region in Western New York. And with all that weather, we could be in king bloom at the end of the week, depending on what your variety is. And it looks like there's more 60s and 70-degree weather, even in the long-term forecast. I know the long-term forecasts are just a rare guess, but we could have a warm bloom. And even if we do, it could change suddenly. We've seen these things happen. It can be 70 one day and 50 the next day, as is predicting for some of the Hudson Valley sites after Thursday. And you're just, so you don't know. But I think there's going to be more weather, and we should be fairly cautious. Now, what happens if you had a lot of fire blight last year? Are you worried about carryover inoculum? I inoculate the heck out of our trees in Geneva, and I don't really get that much return carryover fire blight. But if you are worried about it, or if you have a really vigorous block and a high susceptible variety, you might want to consider one of those prohexadione calcium applications at Pink, just to slow any migration through tissues that might occur in plants over a bloom period. A little bit of fire blight sneaks in, starts running wild in your plants. The Prohex will slow it down. And we've had two programs that I show in that article that I just posted, and usually involving 6 ounces per 100 gallons at Pink. And that should get a little bit of shoot and blossom blight if you can get those pedicel cell walls thickening. And the other option that's very popular for in Michigan is to do 2 ounces of calcium per 100 mixed with 1 ounce per 100 of Actigard, or as I've referred to in the article as acylbenzolar S-methyl. Actigard is the one you should look for. There's only one product of this. And that one you do a little bit at pink and petal fall. And that's been very helpful. My colleagues in Michigan have looked at it. We've looked at it, and we've both been very happy with stuff in our region. And there goes all my notes. Okay. So if you have a low vigor block, you know, these ProHex things might not be very helpful. And one of the things that Dan Donahue and I were talking about today, if it starts freezing and gets really cold in the low 50s, you know, maybe it might not be as effective as well. Because, you know, plants need to take these materials up and they need to metabolize them because they are PGRs and they are used for other things like bitter pit and other stuff. And we're just using them to try to make the cell walls thicken up extra so that they can stop the migration of fire blight through the tissue. Now we've had streptomycin resistance. And since we're going into bloom, I'm just going to give you a little bit of information on, I'm going to move my thing around. Okay, the model shows inspection for Thursday. New model shows no infection this week. Well, that's everywhere I've looked at. I have to look at Yorktown, Randy. We're still seeing infections for the week for NUA. I'll check your site afterwards. And let's see. So as we move into bloom, what we're recommending for people who don't have any incidents of streptomycin resistance in the last 3 seasons, start off with your streptomycin at 24 ounces per acre. Keep the regulate in there to enhance the effectiveness in it. And, you know, Terence mentioned not to worry so much about a little bit of injury here and there from thinning and other stuff. You know, the level of burning that you see from regulate plus strep will just let you know you got it inside the leaf in many instances and isn't of that much consequences. Now, if you need a later application after the first really nasty fire blight period, which could happen any moment, my guess it might probably be next week, is that try to consider using Kasumin. Just, it's a different mode of action. It's a heck of a lot more expensive, but it will, if you rotate this with strep, it should keep you from ever having an antibiotic resistance problem. And if you ever have a failure from either one of these antibiotics, get in touch with one of us or one of your regional team members so that we can talk about taking a sample to look for fire blight or antibiotic resistance and see what's going on. And with that, if you do or have been told you've had streptomycin resistance as of last year, we had a lot of sites with it. I'm going to recommend some different things. I'd recommend starting with kasugamycin, marketed as Kasumin, about 64 ounces per acre and 100 gallons of water. Putting regulate in with it as well to enhance that uptake. The one thing about kasugamycin that gets a little bit worrisome is it breaks down fast in UV light. In that particular case, if you want to do the best with this, I'd put it on at the end of the day, if possible, if you can do an evening spray, just to get it in there. We've seen some instances on really sunny days where we were a little mystified, and several people have been mystified as to why it wasn't working as well, and we suspect that light breakdown could be one of the issues. Now, okay, you started with kasugamycin. What do you do next? Because it probably won't be the only spray that you need to make. Well, interestingly enough, if you need a later antibiotic, use oxytetracycline, one of the oxytetracycline products at the highest rate. If I were to go out with oxytetracycline, I would try to make this second application at one of the high or moderate to high risks. And the other one that you can use, and this is going to sound pretty crazy, is if you can get your hands on it, I would recommend Blossom Protect. Right now, across the country, from Washington to Michigan to even Pennsylvania, Blossom Protect has been about one of the only biological products that's actually performed very, very well against fire blight. And it's recommended to go out at 1.25 pounds per acre with this buffer protect that comes with it at 8.75 pounds. It's OMRI listed, but it actually works pretty well. And in the chat, I will post how you get it. I've been given the contact information for it. Let me get off Randy's little message here. Boop, bam, and that's who to contact for getting it, because we can't find it anywhere when we wanted to order it for some of the antibiotic crises around the station. Okay, well, you might need a third application. If you're getting towards the very end of the bloom period and you need one more, this is where to go back with Kasumin again. If you're in a history of strep resistance or you had it last year, try to use Blossom Protect during bloom, and don't use Blossom Protect on any trees going into petal fall in case we have a wet petal fall and you get a little bit of russeting. Also, it seems to be in many cases that we're learning that even though when trees are going into pedifall, the potential for a fire blight infection is still very intense. And many of my colleagues in Washington were noticing that sometimes nearly pedifall infections can be worse than full bloom. So in this case, if you're getting back towards the end of bloom and you're in that pedifall region, but there's still one flower on the tree, you can legitimately apply Cassumin and make that your last application. For those who have strep resistance, if you are in a normal non-strep resistant scenario, you can continue to use your various streptomycin as is labeled. And I think that is all of what I wanted to say for fire blight. Try to get us back on chat, and I will answer some questions in there. What's the timing and rate for the ActiGuard and ProHex? Since I have a second, I will go ahead and activate that. Yep. And you can check that link. It has all the details in it. But I would go out, if you're early to even late pink, Mark, drop that it's 2 ounces per 100 gallons. Or I would say 2 ounces per your tree row volume mixed with 1 ounce per your tree row volume, or 100 gallons of acylarbenzol or S-methyl. I just want to make sure if you go out with a tree row volume that you get that 2 ounces plus that 1, and that goes out at pink and pedifall for that combination one. Good. I will stop talking and answer questions. Can you tack, mix, strep, and activate? Goodness. Wonder what activate is. Post in there if activate is a surfactant. You can mix a lot of things with strep. Oh, ActiGuard. Yeah, you can do that. I don't think it's a problem. I mean, we've mixed them together, but usually what ends up happening is in research trials is the strep overwhelms anything that we've seen with ActiGuard. But it would be a good idea if you want to start boosting defenses for later shoot blight. It's not a bad idea, Richard.
Okay. Well, thank you, Kerik.
I'm muting.
Yep. So we're gonna go ahead and move on. Introduce Mike, the next speaker.
Janet, I'm going to post to the chat the Lake Ontario Fruit Program YouTube channel and the Lake Ontario Fruit Program webpage, where we'll be posting the videos afterwards.
All right, so with that, I'm going to introduce our final speaker of the day. Next up, we have Dr. Jaime Pinero, who's joining us from the University of Massachusetts, and he's going to be discussing insect management at pink.
Thank you, Mike. Just give me a second here. So can you hear me?
Yes, we can, and we can see your screen fine. Thanks.
Thank you. So today, what I will do is to discuss 5 insect pests, for 4 insects and mites that are possibly present in your orchards. It's going to be very brief. And I will discuss very briefly monitoring, action thresholds, and the last slide is going to be a spray table presenting the materials that can be used to control this pest if there is a need. So it is always a good idea to monitor for pests. And in the case of tarnished plant bug, European apple sawfly, you can use, as you know, white sticky card. And for these 2 pests, no lures are available. So tarnished plant bug is now a little late to start monitoring, but activity is very, very low at this moment in Massachusetts. For plum curculio, well, there is a lure that can be used to monitor. It's a combination of the pheromone and benzaldehyde. And the best timing for monitoring is at pink, starting at pink. So it's relevant the timing at this moment for this presentation. So a second option for monitoring plum curculio is called the trap tree approach, and involves using the lure, which is the grandizoic acid and the benzaldehyde. Then you can bait branches of one single tree in the perimeter of one block, and then you can focus on monitoring on this particular tree. So just in a few words, because I will not be discussing this in detail, is when you don't have fresh injury after the petal fall spray, then there is no need to spray. Timing. So as I was mentioning before, for tarnished plant bug, well, we deploy the traps in Massachusetts at the silver tip stage. European apple sawfly, now it's time to deploy the traps. for plum curculio, at late pink is the best time to deploy the lures for the trap tree approach. And then for oriental fruit moth, when early April will be a good timing for deploying the pheromone-baited traps. Positioning, well, you know about the Tarnish plant bug 2 feet above the ground. You can switch to head height for European apple sawfly. For plum curculio, the trap tree approach is one single tree that you can deploy the lures in the perimeter, in the canopy, and that will be at tree height. So European apple sawfly, that was not included in the table because egg hatch is taking place now. So it depends on the weather, but I don't think it's complete by now. It's supposed to be completed or expected to be completed by petal fall. So is it too late to apply oil? I think it's getting late to apply oil, but if you can decrease the rate, then you have a good chance to still kill some of those, suffocate some of the eggs. So you can apply 1 gallon rate per 100 gallons of water. And you can also tank mix with Apollo, which the active ingredient is clofenticynide, which is a mite growth regulator. The action thresholds for Tarnish plant bug are by the late pink stage is 5 per trap. That will be the density at which you can spray an insecticide against Tarnish plant bug. And if you are monitoring for terminals, then if you have 2 or 3 bleeding sites per 10 terminal sample, it will be justified to spray an insecticide. However, in Massachusetts, most growers are not spraying against Tarnish plant bug or European apple sawfly. For the last 10, 15 years, the populations have been lower than the action requires. For example, we deployed more than 240 traps in 13 orchards in Massachusetts. That was in early April. Then we have 46 traps in 2 orchards in New Hampshire. And so far, we have found Tarnish plant bug in 3 weeks, only in 5 orchards out of 13. So the other 8 orchards, it has been 0 captures. And in the 2 blocks in New Hampshire, we have found 0 Tarnish plant bug in 3 weeks. So this means that Tarnish plant bug captures are very low in Massachusetts, and therefore we're not recommending in Massachusetts to spray against Tarnish plant bug. There is no need. For European apple sawfly action thresholds, well, it depends on the cumulative captures from pink to petal fall using the white sticky cards. And the action threshold is when you have an average of 4 to 5 per trap by petal fall. If those blocks didn't receive a pre-blooming insecticide, the threshold will be higher, 6 to 9 by petal fall per trap in blocks that had an insecticide before bloom. Regarding plum curculio, well, so far we have not seen any plum curculios in Massachusetts in different orchards. What you can see in the screen is that starting in the year 2000, using lures and traps, we were able to determine that the cumulative heat needed for plum curculios to become active, that would be the onset of captures, is around 228 degree days and base 43, starting in January 1st. But then when I came back to Massachusetts and after being away for 15 years, then in 2018, the first curculio was captured at 220 degree days. That was May 2nd. In 2019, the first captures took place at 214 degree days. That was April 24th. And in 2020, the first captures were at 203 degree days, base 43. So the 9-year average is 216 degree days. So we were expecting this year to find plum curculios at that moment, but it hasn't happened. So the weather has not been conducive for plum curculio activity. Therefore, we're not finding any plum curculio yet. I also can discuss action thresholds for plum curculio, but very briefly because I'm not going to be describing the trap tree approach. But the idea is that you can monitor for plum curculio using the pheromone and benzaldehyde, and this trap tree provides very good information on plum curculio activity for one block, which is, it could be 1 to 3 acres. The trap tree needs to be weighted at early pink, and that will be maybe getting a little late for that. But then you focus only on that. Let me just go back here. You focus on that trap tree for monitoring. So you apply the spray at petal fall, covering the entire block, and after that you focus only on the trap tree. And if there is fresh injury, there is a need to spray. If there is no injury, then there is no need to spray. So I think I went a little fast on my presentation, but my focus was on monitoring and action thresholds. And the last slide that I have are the insecticides that can be applied at pink if there is a need. So I was taking this information from the Cornell guide, and basically at petal fall, at pink, you can basically use pyrethroids, neonicotinoids. There is one material which belongs to a different chemical class, which is in Belief, and the one that is in the 22A group, which is Avant, can also be used at pink against the different insects. I only included tarnished plant bug, European apple sawfly, and aphids in this table, and you can see that the rating of 1 is poor, the rating of 2 is fair, and the rating of 3 is good, according to the New York, the Cornell guide. So with this, I am concluding my presentation. If there is any questions, thank you.
All right, thank you very much, Jaime. And if anybody has any questions, feel free to type those into the chat box.
Thank you.
Thank you. And thank you to all our speakers. There's still a little bit of time if you want to put.
There's one more. There's one question in the chat box.
Great. Is anyone in the Ontario region using grandocytic acid lure for curculio? I know Jaime is not from the Lake Ontario region.
No, but I suspect no. The answer is no. I suspect my.
Well, thank you again to all the speakers. If you would, thank you. I'm going to share my screen. A couple of things to.
I had a question for Dan.
Sure. Dan, are you there?
Yes, I am.
Dan, my Honeycrisp are in bloom today, and I wanted to spray them tomorrow when it's warmer with the Apogee spray. Is that a good idea?
What county are you in?
Orange County.
Oh, I mean, are you in full bloom, or are you still almost there?
They're just opening today.
Yeah.
Some trees
good,
will be in full tomorrow, but.
What's the temperature out there right now?
It's in the 50s today.
Yeah, too cold, so it's gonna be a little warmer tomorrow, I believe.
Yeah, it's gonna hit 65 at 4, but be windy, so it's planning to hit them at 11 o'clock when it's like 53.
Well, we'll hold our breath on that.
All right.
Yeah, and then I think we're going to have rain come in, so you might not have a chance. But if you had a chance, you need 8 hours without a rain shower.
Right. Well, I think I'll get that.
Yeah, I would worry about heat more than time at this point.
All right. We'll give it a shot. Thank you.
You're welcome, Jeff.
Thank you. And highlighted there on the slide, this meeting is going to be posted on our YouTube channels, and they've been put in the chat box, the links to both our websites for Lake Ontario Food Program and an Eastern New York Commercial Horticulture Program on our YouTube channels sometime tomorrow. Next week, same time, same place, Zoom, we're going to have more detailed about bloom thinning with the use of Pollen Tube Growth Model with Dr. Terence Robinson and others. So keep that on your calendars, and we'll be sending out that link through our usual channels relatively soon. And I really wanted to, I'm going to surprise somebody today. I'm really pleased to tell folks that Liz T, our technician, tomorrow would be our anniversary for 15 years with the team. So for those of you who are familiar with our Lake Ontario fruit team in Western New York, she is the longest running member on our team. I started in a year after her, and Mario started after that, and Janet and Mark are recent members of the teams, and she has just done a phenomenal job. Whatever we ask, she does not treat it like a job. She treats it like a career, and she really does the lion's share of the bulk of the work behind the scenes. So I really want to take this opportunity just to acknowledge this in front of folks. And if anybody wants to go in the reaction box and click a little hand wave or an okay, I see some doing that, or they can unmute themselves if they want. But I just wanted, it popped up in my email box, and I knew she had started before me, but I didn't know it was 15 years. So thank you, Liz, for all you do for us. We could not do it without you and your dedication.
Thank you, Craig.
Is there anything else that we need? I know we're running a little bit over, and we appreciate everybody's patience. And if not, we hope to see folks next week at our Pollen Tube Growth Model bloom thinning meeting statewide. Thank you, folks.